The graph indicates how Australia's population is aging by showing the past and projected percentages of the population aged 65 and over. We want to use a linear approximation to predict the percentage of the population that will be 65 and over in the years 2040 and 2050. Do you think your predictions are too high or too low, and then why? Well, what we want to do first is, since we want to know the years that are 2040, 2050, we want to be able to estimate at 2030. So let's just take a look at this graph here. Okay, so we know that if this is 2000, this is 2010, this is 2020, and then this is 2030. So we're going to go ahead and then estimate here. So let's go ahead and draw a line. Okay, so from here, which is 2030, we're going to go to this point on the graph. Okay, move that over just a little bit. Okay, and so therefore, then we want to figure out, okay, what's going on from here. So at this point, we're going to get to what point here. So we can estimate this point, okay, and we can call this point the year of 2030. So we can estimate this point to be somewhere between 21 and, excuse me, not 21, up all the way around. It's going to be the year 2030, and that's 21%. Okay, so therefore there is the ordered pair, or the line that we're going to use. And so we're going to extend this tangent line to, again, 2030 to 21. And then we're going to extend it to the t-axis. So let's go ahead and do that. So we're going to extend this line from here to the t-axis. Let's go ahead and do that again. And so we're going to use 1900 as the t-intercept. So therefore, by using the graph, we can say that this represents the t-intercept. Okay, and so now what we're going to do is we're going to draw a perpendicular. So the perpendicular that we're going to have goes from here, starting at 1900, to this point up here. So therefore, we're going to have a perpendicular here, and we know the distance from here to here is 21. And if this is 1900 and that's 2030, then the distance from here to here is going to give us 130. Okay, so what we want to do is, we want to now write out our linearization. So the linearization, okay, which is going to be L of t, is going to equal P of A plus P prime of A times T minus A. Okay, and we know that the ordered pair is 2030 and then 21. So we're going to let A equal 2030. So therefore, we can now write this as L of t, which is going to equal P of 2030 plus P prime of 2030 times T minus 2030. So we have two ordered pairs of this line. We have 0, 1900 and 0, and then 2030, 21. So we know that P of 1900 is equal to 0. And we know that P of 2030 is equal to 21. So now we're going to find P prime of 2030, and that's equal to P times 2030 minus P of 1900 all over 2030 minus 1900. So that's going to be 21 minus 0 over 2030 minus 1900, which is 130. So we have 21 over 130 as the slope. So now we're going to plug it into our formula in part 2. So we're going to have P of 2030, which is 21, plus P prime of 2030 is 21 over 130. And that's equal to T minus 2030. So now from here, we can now go ahead and answer the question to predict the percentage of the population that will be 65 and over in the years of 2040 and 2050. So L of 2040, we plug it in. We got 21 plus 21 over 130 times 2040 minus 2030. And if we go ahead and multiply that all out, we're going to get approximately 22.6%. Then we want to find L of 2050. So that's going to be 21 plus 21 over 130 times 2050 minus 2030. And that gives us approximately 24.2%. So now the question says, do you think your predictions are too high or too low, and why? Well, these predictions seem too high. So there are probably too high. And the reason is since the tangent line you can see here, so since the tangent line in the graph lies above the graph, at when t is equal to 2030.